Good morning, my dear student. Today I discuss the new topic transpose of a matrix. What? Transpose of a matrix. So look at what is the transpose? Transpose of a matrix. So it is a very important and very simple also. Transpose of a matrix. Suppose if a matrix, it is the matrix A, B, C, D. It is a matrix A, B, C, D. Then if you want to transpose, A transpose is given by A, B, C, D. That means every row should be converted in column and column also in row. And that is called the transpose of a matrix. So transpose of a matrix is defined as if you transfer, it was at first it was the row A, B, I convert this one in column, C, D, row, I convert it in column, and that is called the transpose of a matrix. So my students, transpose of a matrix is defined as if you interchange the column and row, column to row, row to column, and that is called the transpose of a matrix. It can be also 3 cross 3 matrix. Or 2 cross 2 matrix, 2 cross 3, any numbers, but it should be what one definition is that it should be the convert every row and column. This row converted in column, and that is called the transpose of a matrix. Next, so I think you understand what is the transpose. Next is symmetric matrix. Next point is what? Symmetric matrix. Symmetric matrix. Look here, symmetric matrix. If a transpose equal to, if a matrix whose transpose equal to A, then it is called the symmetric matrix. Symmetric matrix are that matrix whose transpose equal to A. That means if a matrix, if you want to transpose the matrix A, then you get A, then it is called the symmetric matrix. So symmetric matrix are that matrix whose transpose equal to A. If you transpose and you get A, then it is called the symmetric matrix. Next, so I think you understand what is the symmetric matrix. Next, suppose if you want to transpose this matrix 0, 0, 0 and 2, 3 and all the elements are 0. Now, if you transpose this matrix, row should be converted in column, then what we get? This row come in column, then you write 0, 2, 3, again this row 2, 0, 0, again this row 3, 0, 0. Look here, this number is same to same as that. If I transpose this matrix and I get it is the same as that of A, and that is why it is called the symmetric matrix. Okay, my students? So symmetric matrix are that matrix whose transpose equal to same to same A. And it is called the symmetric matrix. That means if the matrix is A, if you transpose this matrix and you get the same to same, it is called the symmetric matrix. If you did not get the same to same, it is not a symmetric matrix. So I think you understand what I am going to discuss in this class. So symmetric matrix are that matrix whose transpose is same to same. Look here, if I transpose this matrix and I get also same to same as it is A, it is also equal to A. That is why it is a symmetric matrix. Okay. Next, skew symmetric matrix. Skew symmetric matrix. If you transpose this matrix and you get minus A, then it is called the skew symmetric matrix. Suppose I write the matrix is like this. If I transpose this matrix, then I get minus 2, minus 2 and all elements are same. Now my dear students, if I take the minus common from this matrix, then I will get 0, minus 2, minus 3 and 2, 3 and all elements are 0. So this is equal to this matrix. If I transpose, it is the same to same as A, so it is a skew symmetric matrix. Because in this cases what I have done, this row come column, this row again column, this row again column. And if I take the common minus from this side, then I get same to same as it is as A. So I get if a matrix whose transpose is same to same minus A, that is why it is called the skew symmetric matrix. So what is the difference between the symmetric and skew symmetric? In case of the symmetrics, you get same to same A, but in case of skew symmetric matrix, you get minus A. That is why it is called the skew symmetric matrix. So my dear students, I think you understand what I am going to discuss. In case of the skew symmetric matrix, you get how much? A transpose equal to minus A. A transpose equal to minus A, and that is called the skew symmetric matrix. Okay? But in case of the symmetric matrix, A transpose equal to A, but in case of skew symmetric matrix, A transpose equal to minus A, and that is the difference between symmetric and skew symmetric matrix. So I think you understand. Next, there are some property of symmetric and skew symmetric matrix. They are very important property. Suppose A, B whole transpose, then in case of the product, this can be written as B transpose and A transpose. That means in case of the product, what you do? In case of the products, you have to do like this. In case of the products, just you have to transpose the order will be the change. So that means last number you have to come first and first also come last, and that is the properties of a product of matrix. But in case of A plus B whole transpose, then you have to write here A transpose plus B transpose. Also, if it is the minus A minus B whole transpose, then you have to write here A transpose minus B transpose. But if there is any constant K into A transpose, then K cannot be transpose because it is the constant. Then A should be the transpose, and that is the answer. So my students, I think you understand what I am going to discuss in this class also. Next, I think you understand what are the symmetric and skew symmetric matrix. So these are the properties of the symmetric matrix. Symmetric matrix. Next, some important property I will discuss with you. First property state, it is given if a matrix is symmetric as well as skew symmetric matrix. If a matrix is symmetric as well as skew symmetric matrix, then it is a zero matrix. So my students, I want to discuss with you that if a matrix is symmetric as well as skew symmetric matrix, then it is a zero matrix. So look here, A is symmetric as well as skew symmetric matrix, then prove that it is zero matrix. You have to prove that it is a zero matrix. So question is given, if a matrix is symmetric as well as skew symmetric, that means it is given that if a matrix is symmetric as well as skew symmetric, then it is a zero matrix. So my students, you have to prove that if a matrix is symmetric as well as skew symmetric, then it is a zero matrix. You have to prove. So my students, look here. It is given that the matrix is symmetric as well as skew symmetric matrix. You have to prove that it is a zero matrix. So my dear students, look here. At first it is given it is a symmetric matrix. A is symmetric matrix. That means A transpose equal to A. Again, A is skew symmetric matrix. Therefore, A transpose equal to minus A. So it is the first equation and it is the second equation. So from first and second, left side are equal. Therefore, right side first and second, a equal to minus a come this side, therefore twice a equal to 0, therefore equal to what? 0. A equal to 0 means it is what? 0 matrix. So my students, I already proved that if a matrix is symmetric as well as is symmetric matrix, then it is a 0 matrix. So I think understood. So what I am going to discuss next question. There are so many results you have to prove that. Suppose the question given that A and B are symmetric matrix. You have to prove that P equal to AB minus BA. What type of the matrix is? What type of the matrix AB minus BA is? That means AB minus B is the symmetric or is symmetric. You have to prove. So my students, in these cases, it is given that it is a symmetric matrix. Since it is a symmetric matrix, therefore, if you want to prove it is a symmetric or is symmetric, then in such cases you have to transpose the both sides. You have to transpose on both sides. I already transpose on both sides. Then transpose come on whole matrix, and all matrix it will be the term. If transpose come this side, then come this side. But in case of the product, it will be the reverse order. B transpose and A transpose minus A transpose and B transpose, reverse order, and B transpose equal to B, A transpose equal to A transpose equal to A, and that is also B. If I take common minus, therefore AB minus BA, then I will get how much? B. So if I transpose a matrix and I get the minus B, so it is a what? Symmetric matrix. Hence, this matrix is what? Symmetric, because I transpose this matrix, and I already get what? Minus P. That is minus of that matrix. That is why it is a symmetric matrix. So my students, I think understands. Symmetric and symmetric, there is only just difference. In case of the symmetric, just you get what? Transpose equal to A. But in case of symmetric matrix, transpose equal to minus A. That means I transpose this matrix and I get what? Minus B. That means it is a symmetric matrix. So like this result are very important for you. Next question. Suppose A is a matrix, any matrix 1, 2, 3, 4, and B is also another matrix 2, 3, 4, 0. Now you have to prove that A plus B whole transpose equal to A transpose plus B transpose. Like this result you have to prove. In these cases, at first you have to find what? A plus B. You understand? At first you have to find A plus B. That means A and B should be added. So when you added these two numbers, you get 3. Added this number 5. Added number 7 and added number 4. Now I transpose on both sides. If I transpose on both sides, then I get row should be come in column and column also row. So I get A plus B whole transpose. A plus B whole transpose, then I get this matrix 3, 5, 7, 4. Because row should be come in column, and I get A plus B whole transpose. Now if I want to find the A transpose, then 1, 2, 3, 4, and B transpose I get 2, 3, 4, 0. Now I want to add A transpose plus B transpose. If I want to add, then what happen? Row 3, and first element added 4, second 5, and third 4, and this is equal to, look here, these both sides are equal. Yes, it is the 7, and these both sides are equal. That means A plus B whole transpose equal to A transpose plus B transpose. This result, like these questions, you can also prove using this method. And there are so many questions in 3.3 exercise. Suppose plus, minus, into, any questions you can prove using this transpose matrix. So my students, look here, in case of the 3.3, there are so many questions you can put with this matrix. Suppose one type of the questions is given every square matrix. Square matrix are that matrix whose row and column are equal. Whose row and column are equal, that is called the square matrix. Every square matrix can be expressed as the sum of symmetric and symmetric matrix. So my students, it is given every square matrix. That means every square matrix you can prove that every square matrix can be expressed as the sum of symmetric and symmetric matrix. So look here, suppose it is the symmetric matrix, A is the symmetric matrix, is square matrix. A is the square matrix. A can be written as half of A plus A transpose plus half of A minus A transpose. If we take the common half, then you will get, if we take the LCM, then we get how much? A. So it is equal to A. Now I think it is the P and it is the Q. If I want to transpose this matrix P transpose, if I want to transpose the matrix P, then I get how much? Half of A plus A transpose, and it is the whole transpose. Then you get how much? Half of this transpose come this side. Again transpose and transpose, you get how much? A. Because A transpose, again transpose, you get how much? A. So P is same to same as it is P. That is why P is symmetric matrix. So I get it is a symmetric matrix. Next, in case of the Q, suppose it is a Q. So Q equal to half of A minus A transpose. If we transpose on both sides, then I get half of A minus A transpose whole transpose. Then this come this side, then I get A transpose minus A. Therefore, if I take the common half on both sides, A minus A transpose and equal to minus Q. So Q is symmetric matrix. Because if I transpose this on both sides, and I get it is a minus Q. That means as it is Q but it is a minus, that is why it is a symmetric matrix, and P is the symmetric matrix. So A can be expressed as the symmetric and symmetric matrix. That means every square matrix can be expressed as the sum of symmetric and